Welcome to session 5 video. In this video, we are going to discuss diagonalization of matrices by using orthogonal transformation. Orthogonal transformation definition: a square matrix A is said to be orthogonally diagonalizable if there exists an orthogonal matrix n such that n transpose an equal to D. Since n is orthogonal matrix definition is if any matrix is orthogonal provided that n transpose n equal to identity matrix, then the matrix is called orthogonal matrix. In this case, n is a normalized model matrix. Always n is orthogonal matrix, so that if it is orthogonal, then their transpose and inverse are the same. After using this transformation, orthogonal transformation, A transforms into diagonal matrix D. This process is called orthogonal transformation or orthogonal reduction. Working rule: for the given matrix A, first we need to find eigenvalues. If it is 3 by 3 matrix, we can get lambda 1, lambda 2 and lambda 3. It is step 1. Step 2, corresponding to each and every eigenvalues, find eigenvectors. Then we need to verify that eigenvectors are pairwise orthogonal. Step 3, we need to find the normalized model matrix capital N after normalizing each and every eigenvectors as columns. Step 4, find N transpose and A into capital N. Then step 5, compute N transpose AN, which is automatically equal to the diagonal matrix D. Diagonals are nothing but the eigenvalues of the given matrix A. There are 5 steps involved in this topic. Problem number 1. Diagonalize the matrix A equal to, it is 3 by 3 matrix, by means of an orthogonal transformation. Solution: we need to diagonalize this matrix. Already we have seen the working rule. By the working rule, step 1, to find eigenvalues. For finding eigenvalues, we need characteristic equation. Since it is 3 by 3 matrix, so general characteristic equation is, it is lambda cube. Please change it into lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Where S1 equal to sum of the diagonal 3 plus 3 plus 3, it is equal to 9. S2 formula, sum of the minus of the diagonal, answer is 24. S3 formula, determinant of A. Find out determinant of the given matrix A, we get 16. Use S1, S2, S3 values in the characteristic equation. We get lambda cube minus 9 lambda square plus 24 lambda minus 16 equal to 0. This is our required characteristic equation. Now we are going to solve this characteristic equation to get eigenvalues. After solving characteristic equation by using synthetic division method, we get the values of lambdas are 1, 4, 4. 3 eigenvalues exist. Since the matrix is symmetric, the orthogonal transformation applicable only for symmetric matrices. Now we are going to find the eigenvectors of each and every eigenvalues. Let us consider the vector capital X as x1, x2, x3. 3 unknowns we have taken. Be an eigenvector corresponding to lambda. The eigenvector formula A minus lambda I into x equal to 0, in which we have to substitute A matrix value, then lambda and identity matrix. Then after getting subtraction, we get 3 minus lambda 1 1 1, 3 minus lambda minus 1 1 minus 1, 3 minus lambda into x1 x2 x3 equal to 0 0 0. Then we can substitute lambda values for finding the eigenvectors. Case 1, suppose lambda equal to 1, then the equation 1 becomes 2x1 plus x2 plus x3 equal to 0, x1 plus 2x2 minus x3 equal to 0, x1 minus x2 plus 2x3 equal to 0. Now you have to choose any two different equations. For that you have to apply cross multiplication rule. This is called cross multiplication rule. After applying this rule, we get x1 divided by minus 1 equal to x2 divided by 1 equal to x3 divided by 1. Therefore, the first vector is minus 1 1 1. Then case 2, if lambda equal to 4. This is second eigenvalue. Substitute this eigenvalue in equation number 1. We get these three equations. Since these three equations are similar to each other, so you can select only one equation among these three. So consider the first equation x1 minus x2 minus x3 equal to 0. For solving this equation, you have to assume any one variable equal to 0. You have to assume third variable x3 equal to 0. Therefore, x2 value becomes 1, x1 value becomes 1. Therefore, x2, the second vector, formed as 1 1 0. Then for finding the third vector, you have to assume x3 equal to general A, B, C. Now we are going to apply cross multiplication rule for first vector and second vector. We get A equal to 1, B equal to minus 1 and C equal to 2. Therefore, third vector x3 equal to 1 minus 1 2. So we got 3 eigenvectors corresponding to 3 eigenvalues. Next we want to normalize each and every eigenvectors by taking square root of each and a square root of sum of squares of the values. Minus 1 whole square plus 1 square plus 1 square. The value is 3. Then we need to take square root of 3. Therefore, the normalization of first vector will be minus 1 by root 3, 1 by root 3, 1 by root 3. The same thing we can normalize second vector and third vector. Then we can form the normalized model matrix capital N equal to the first normalized vector consider as first column, second vector consider as second column, third vector goes to the third column. Therefore, its transpose, N transpose, after interchanging rows into columns, columns into rows, we can get N transpose. Now we are going to multiply the matrix A and the normalized model matrix N. We get this answer. After getting this answer, now we are going to take the multiplication between N transpose and AN. After multiplying these two matrices, the answer becomes 1 0 0 0 4 0 0 0 4, which is nothing but diagonal matrix. The diagonals are nothing but eigenvalues of the given matrix A. In this video, we have seen the diagonalization of symmetric matrices by using orthogonal transformation. Thank you.